are going to be talking about more integrals, specifically the integral of e to the x sine of x dx. So now, quick review before we get into this more. There are two common types of integrals. There are more, but these two are the most common. Indefinite and definite integrals. Indefinite integrals are integrals that do not have factors. So for something like our example problem, integral of e to the x sine of x dx. These will always result in some sort of formula as an answer. For the others, we're giving something a little more complicated. Definite integrals have factors on them. For instance, say the integral of 0 to pi e to the x sine of x dx. These are always going to result in a number. What kind of number? Well, it's the area under the curve of the integral. So say if this integral had a curve of something like this, we could draw little rectangles to approximate the curve. That was one was a little too tall there. To approximate the curve, like so. And the area underneath this integral from 0 to pi is the answer to this integral. Now, for this one, we are going to be doing indefinite integral, so I'm just going to cover how to do this problem. So, first we got to write our problem, as always. Integral of e to the x sine of x dx. And then we start by doing a u substitution. So we have u equals e to the x, dv equals sine of x dx, like so. Du becomes e to the x dx, and v, since it gets differentiated, would be the negative cosine of x. Write our formula for u substitutions, uv minus the integral of v du, and plug it in. We have e to the x, negative cosine of x, minus the integral of negative cosine of x, e to the x dx. We can clean this up a little bit by changing it to negative e to the x plus, negative e to the x cosine of x plus, we move this negative over here, plus the integral of e to the x cosine of x dx. So now, we can't solve this anymore, but we can solve this chunk more. So we do exactly that. We do another u substitution. U equals e to the x, dv equals cosine of x dx. That makes du e to the x dx again, and v the sine of x. Rewrite our formula, negative e to the x cosine of x, plus our rewritten formula, uv minus the integral of v du. We plug it in. Now we plug it in. We get negative e to the x cosine of x plus e to the x sine of x minus the integral sine of x e to the x dx. Now basically, once we now that we've simplified this down a little bit, all we do is swap the e to the x and the sine of x. We make a realization. Let me copy it down, see if you, future me can see it. Minus the integral e to the x sine of x dx. We found that this minus our actually plus our problem. Where am I getting? Oh wait, no. Yeah, there is a minus. That minus that is our problem. So we know that if the integral of e to the x sine of x dx equals this, we can move this over and add this. So now we get 2 integral e to the x sine of x dx equals, we have negative e to the x cosine of x plus e to the x sine of x. Sorry, my handwriting is terrible. Divide everything by 2 so we can get rid of that 2 up front. that. And we got for our final answer, the integral of e to the x sine of x dx is equal to, our final answer again, negative e to the x cosine of x plus e to the x sine of x all over 2.